Hello, this is Mrs. Zach again. I am just going to explain a very important theorem that you are going to have to apply and use. It is called a triple theorem because there are three parts. Now this is a theorem that deals with chords. So hopefully you've got your definition of a chord and you know that it is a segment whose endpoints lie on a circle. Well, what I would like you to do first, before we go over the circle packet, I want you to get out a sheet of paper. And I want you to write down the three sentences that you see here. Because this theorem has to do with all three of these sentences. If any two of the sentences are true, then the third sentence must be true as well. So we're going to give you a little test to see if you understand it after you write it down. So you have to write it down first. And the bolded words you might want to underline. Or if you have a highlighter, highlight the bolded words. Now each sentence uses the word line. Doesn't really have to be a line. Could be a segment. Most likely, it will be a segment. So, number one, a line contains the center of a circle. Center is usually the bolded dot you see on a circle. Number two, a line is perpendicular to a chord. And we know we're looking for that right angle symbol, the box. And number three, a line bisects a chord. We're looking for those tick marks to show the point of intersection is the midpoint. So here comes the test. Once you've written the three statements down, I want you to just look, listen, and learn. We're going to state the conclusion. Now if you want to draw these diagrams out, you can. Or you could just look, listen, and learn. Let's check out the first one. I see tick marks, and I see a box, which designates a right angle. So if I look at my triple theorem, I've got perpendicular and I've got bisects. I do not have center. I do not see a bolded dot. So my conclusion is going to be that segment CD must contain the center of this circle. So I'm going to write that conclusion down. Segment CD must contain the center of the circle. Okay, and also I could say CD is the diameter of the circle. That would be a true statement as well. Alright, so let's go with number two. Again, these are just quick examples to make sure you understand this triple theorem. Number two, I see a bolded dot. That is the center. That is number one. Check. I see tick marks. That means bisects. That is number three. Check. I do not see a right angle. And so, my conclusion would be that segment AB is perpendicular to segment CD. Or you could write that segment CD is perpendicular to segment AB. Alright, so that's the conclusion for number two. Alright, let's look at one more example. Okay, now I've hidden that triple theorem, but you guys have it written on your paper. So check out number three. I see a bolded dot. Hi. That means I am the center of the circle. I see a right angle, perpendicular. I do not see tick marks. So, anybody for number three? Come on, I know you're out there, and I know you know the answer. Alright, what do you think it is? Matt, Tiffany, anybody know? How about that CD, and that is supposed to be a D, even though it looks a little weird, bisects segment AB. And so I could put these wonderful tick marks and I am done. Now, that's going to help you determine some things you'll see when we do the problems in the workbook. One thing that it will help you with, the distance a chord is from the center of the circle has to be a perpendicular segment. So a lot of times it'll tell you that segment AB, this chord, is a certain distance from the center. And then they want you to find the radius. Well, here's how you're going to be able to do that. You're going to make a radius and make sure it connects from the center to the end point of that chord. So if they tell you the distance that this chord AB from the center, let's just say they give you a number like 5. And let's say they tell you that the chord length is 24. So AB is 24. Well, we just figured out that it gets bisected. So immediately I'm going to put 12 and 12. Now if they want the radius, I'll just call this circle O. If they want OB, hey, you're going to use the Pythagorean theorem. That is leg squared plus leg squared equals your hypotenuse, which, if you look, I'll make another box there so you can see, is opposite the right angle. That is going to be what I'm looking for. I can call it R or X, and then I would just simply do the Pythagorean theorem. So 25 plus 144 is 169. Take the square root, and I get 13. And that is a famous triple, 5, 12, 13. And so that is how the triple theorem with chords is going to help you determine different lengths. So what I would like you to do, we're pretty much done with this little preview. Now I think we'll be able to fill in the first page of the circle worksheet successfully. So let's go ahead and get out our circle packet, and Mrs. Barrett can put in the next video.